Hello everyone, in the second video of binomial expansions, we learn how to solve binomial problems and how to do binomial estimation. Let's quickly recap what is binomial expansion in general. So that is a plus b to the power of n equals to a to the power of n plus n choose 1 times a to the power of n minus 1 times b plus n choose r times a to the power of n minus 2 times b squared plus so on plus n choose r times a to the power of n minus r times b to the power of r and plus so on plus b to the power of n, where n is natural number and n choose r equals to n factorial over r factorial times n minus r factorial. That is binomial expansion. So let's firstly see, to solve binomial problems is that to find individual coefficient in the binomial expansion. In the expansion of a plus b to the power of n, the general term is n choose r times a to the power of n minus r times b to the power of r. Now let us see an example question. So the question asks you to find the coefficient of x to the power of 4 in the binomial expansion of 2 plus 3x to the power of 6. From 2 plus 3x to the power of 6, we can define that a equals to 2, b equals to 3x, and n equals to 6. So what we need to do, we need to find the term includes x to the power of 4, which means the indices of 3x must be 4, so we must have 3x to the power of 4. That is b to the power of 4. So which term includes that? So look at here. We know r equals to 4. So the term includes n choose r, that is 6 choose 4. So we have x to the power of 4 term equals to n choose r, that is 6 choose 4, times a 2 to the power of n minus r, that is 6 minus 4, that is 2, times b to the power of r, that is 3x to the power of 4, equals to 15 times 4 times 81, x to the power of 4, equals to 4,860 x to the power of 4. So we find the general term of that, so we can see the coefficient of x to the power of 4 is 4,860. So for this question, you need to quickly define what is a, b, n, and r. As you know all of them, then you can define which term it is, and now you can find the coefficient of that. Let's move on to see the second question. So the second question for part A, it asks you to write down the first three terms. In ascending powers of x of the binomial expansion of 1 plus qx to the power of 8, where q does not equal to 0. So we know how to do it from the previous lesson. So 1 plus qx to the power of 8 equals to 1 to the power of 8 plus 8 choose 1 times 1 to the power of 7 times qx plus 8 choose 2 times 1 to the power of 6 times qx to the power of 2 plus so on. So we have write down the first three terms. Now we rearrange that. We have 1 plus 8qx plus 28q squared x squared. You can use a calculator to find these values. So we have done the part A. Part B is said that given that in the expansion of 1 plus qx to the power of 8, the coefficient of x is minus r, and the coefficient of x squared is 7r. Find the value of q and the value of r. From the previous question, part A, we can see the coefficient of x is 8q. So we write down that 8q equals to minus r. And for the coefficient of x squared in part A, we have 28q squared times x squared. So the coefficient of that is 28q squared. So we have 28q squared equals to 7r. Now we have written down all the equations. It's time to solve them. So what we can do, we write down this is the first question, and this first equation, this is second equation. So from second equation, we can have r equals to 28q squared over 7 equals to 4q squared. Now we substitute equation 3 into the equation 1. We have 8q equals to minus 4q squared. Rearrange that, we have 4q squared plus 8q equals to 0. And we take out 4q out of the bracket, we have 4q times q plus 2 equals to 0. We got q equals to 0 or q equals to minus 2. Since the question said that q does not equal to 0, so we have the answer. Since q does not equal to 0, then q equals to minus 2. So we have r equals to 4 times minus 2 squared equals to 16, as you substitute back to the equation 3. So we have done this question. We find the value of q, and it's q equals to minus 2, and the value of r, that is 16. Now we have learned how to use a general term to solve binomial problems. Let's move on to see how the binomial expansion to do estimation. If the value of x less than 1, then we can obviously see that x to the power of n gets smaller as n gets larger. So if x is small, you can sometimes ignore larger powers of x and then to estimate a value. For some example question, so find the first 4 terms of the binomial expansion in ascending powers of x of 1 minus x to the power x over 4 to the power of 10. So we know how to do it. We have 1 minus x over 4 to the power of 10 equals to 1 to the power of 10 plus 10 choose 1 times 1 to the power of 9 times minus x over 4. So plus 10 choose 2 times 1 to the power of 8 times minus x over 4 to the power of 2 plus 10 choose 3 times 1 to the power of 7 times minus x to the power of 4, minus x over 4 to the power of 3, and then plus so on. So I have written down the first 4 terms. That equals to 1 minus 2.5x plus 2.8125x to the power of 2 minus 1.875x to the power of 3 plus so on. You can use a calculator to calculate it. Let's write it larger, so that is 10.1. Hope you can see it clearly. Okay, now move on to the part B question. So for part B, it asks you to use your expansion to estimate the value of 0.975 to the power of 10, giving your answer to 4 decimal places. So we can use the expansion to estimate this value. So we let 1 minus x over 4 equals to 0.975. What we have x over 4 equals to 1 minus 0.974. So x over 4 equals to 0.025. So x equals to 0.1. Now, we can substitute x equal to 0.1 into the expansion for the 1 minus x over 4 to the power of 10. So we substitute x equals to 0.1 into the expansion for 1 minus x over 4 to the power of 10, which means 0.975 to the power of 4 to the power of 10 estimate equals to 1 minus 2.5 times 0.1 plus 2.8125 x, that is 0.1 squared times 0.1 squared minus 1.875 times 0.1 cubed equals to 1 minus 0.25 plus 0.02825 minus 0.001875. equals to 0.77625. And the question asks you to give your answer to 4 decimal places. So we have 0.7763 to 4 decimal places. That is the answer. So for estimating, you need to know how to link your expansion to the value you are going to estimate. In this case, we will find the value of x, and then you can substitute x into the expansion. Thus, you can get the estimation of the value. So here is the end of the lesson. In this lesson, we know what is the general term is in the expansion of a plus b to the power of n. That is n choose r times a to the power of n minus r times b to the power of r. And we know how to use the binomial expansion to do the estimation. So the first few terms in the binomial expansion can be used to find an approximate for complicated expression. You can pause the video at any time to make some notes. Thank you for watching.